Hi, this is Allison from East Cobb Tutoring Center, and here comes some basics for summation notation. When we write things in summation notation, we're talking about a series. We use the Greek letter sigma to represent sum. There we go. That's a 4, and then some kind of equation would go over here, maybe 3n minus 5. What this notation is telling us to do is to plug integers into this formula, starting with 1 and ending with 4. So if I plug in 1, I get -2. If I plug in 2, I get 1. If I plug in 3, I get 4. And if I plug in 4, I get 7. The sigma, the Greek letter sigma, tells me to take these numbers and add them together. So let's see, that's going to be -1, 3, plus 7. My sum is 10. Let's do another example problem. Oops. That is not what I meant to write. I meant to make that be an 8. There we go. And let's do 2 to the n minus 3 power. There we go. All right, so what this is telling me to do is to start with the number 3, plug in 3, plug in 4, plug in 5, plug in 6, plug in 7, plug in 8, and stop. If I plug in 3, I'm going to get 2 to the 0 power, which is 1. Then I'm going to get 2 squared, 2 to the first power, which is 2, and 2 squared, 2 cubed, 2 to the 4th is 16. So I have enough, let's see, 3, 4, 5, 6, 7, I need one more. 32, because when I plug in 2 to the 8 minus 3, it's the same thing as 2 to the 5th. So summation notation tells me to add all of these up. Let's see what we've got here. These guys together make 48. And I've got 12, 14, and 15. So altogether, my sum is 63. All right, let's try one more thing. I do want to point out that on the first equation that I had here, this was an arithmetic sequence, or an arithmetic series because we were adding it up. Arithmetic. And if you look at the numbers, each time I'm adding 3, so that's what makes it arithmetic. In the second example, this is a geometric series because each time I'm multiplying by the same number, the number I'm multiplying by is 2, each time by 2. That makes it geometric. So take a look at this example. We're going to start with n equals 1. And this time, instead of an 8 or a 4, I'm going to actually put infinity. This time it's on purpose. And the number I'm going to put here is 1/3 the n minus 1 power. What this is telling us to do is to plug in 1, so that would give me 1. Plug in 2, that would give me 1/3. Plug in 3, that will give me 1/9. And so on for infinitely many terms. Instead of commas here, I should have put plus signs because we're doing a sum. Sorry about that. All right, so we would be adding this on for infinitely many terms. That'll take a long time. Luckily for us, there's a formula to easily figure out the sum of of a geometric series when it goes to infinity, and as long as the value here that we're multiplying by is less than 1, which we call the common ratio. If the value of r is a fraction less than 1, then we can use this formula to find the sum of infinitely many terms. Here it is. The sum of infinitely many terms is equal to the first term divided by 1 minus the common ratio. So in that last problem, my first term was 1, and my common ratio was 1/3. So the sum, if I were to add up all the terms, would be 1 over 2/3, which is 3/2. Now remember, you can only do this formula if it's geometric and the common ratio is less than 1. Otherwise, it's not possible to find an exact value for the sum.